Can we just give a warm welcome to Sam Aaron?
Hello there. So hopefully we're going to have something on the screen in a moment, which is going to be super exciting. How many of you have used Closure? Right, that's pretty cool. How many of you used Overtone? That's awesome, right? Okay, I don't actually develop it that much anymore, but that's probably how you might know me. Me and a friend called Jeff Rose built a really cool music system using Closure as the interface, and that's probably one of the reasons why I'm here in front of this kind of audience. However, what I would like to do today is talk about something completely different. We've seen, what's actually what I was thinking whilst I was thinking, what am I going to talk about, right? Because one of the things I've done recently is, well, for the last quite a while, is never really prepare for any talks, because it's quite exciting to me to think about, what am I going to say? When I go on stage, what is it I'm going to say? And it's always quite exciting, but it turns out that all I do is do a pastiche of my previous talks. So if you were to go to random YouTube talks and just cut and paste bits and put them together in a linear order, that's probably a new Sam Aaron talk. And also, watching these talks today, what I'm doing is actually doing a pastiche of all the previous talks. A lot of the things I'm saying have already been said today. So I don't know if that's going to be exciting or not. What I'm hopefully going to do is try and wrap it up in a different order. And I'm also going to use a fabulously new programming language, which is, I believe is very exciting, called Ruby, to describe these things. And this is like joking aside, languages aren't really that important. Ideas are important, I believe. And I think that one of the beauties of the Closure programming language isn't the language itself, it's all the ideas that have gone into it and that deep thought, that's this beautiful design. And so can we take those kind of ways of thinking and apply them to different domains? And I'm going to use this, so this is my system here, this is something called Sonic Pi that I initially designed and developed, but there's a bunch of really cool people who have helped me build it. And if you want to join in too, it's great. And I'll show you a little bit about it now, but not too much. Later on, I'm going to do a performance-y thing, so you'll be able to see what it can do. But what I'm going to talk to you now for the rest of whatever 17 minutes is this idea about communicative programming. So I've always been interested about thinking about how you might think and reason about programming. And I was always, I don't know, when people said to me and talked about, and go to these conferences, and people always talk about efficiency and making sure the computer's optimized and all these sort of important things that we talk about as engineers, I always sort of felt a bit like I'm not sure if I fully agree with that's the only important thing in the programming world. Because to me, it is important to get the program to be efficient enough, but more efficient than that, maybe that's not necessary. What other kind of efficiencies could we have other than how fast it runs and how much memory it consumes? And to me, I'm interested in about how much cognitive power do I need to reason about this thing? Right? It's all fair and well if this thing runs really fast, but it's taken me a week to figure out, versus something which runs fast enough, but taking me a few hours, which has more business value. Although I hate to use the word business because I'm an academic, and all the work I do is open source and free, and I make music, so it's a bit crazy. But the business value actually, maybe that has some connotation to you, but for me, one of the things I do is I perform in nightclubs with this system, and business value to me is, can I make people dance? And if they're already dancing, can I keep them dancing, right? And so I need to think about what ideas, musical ideas, can I have in my head, and how much effort is it to put them into practice so that I can modify the music as it's performing. So we've already talked a bit about feedback cycles, how they're important. The REPL-driven development is obviously something we all love. And can we take that idea and apply it in different domains? So this system really is sort of a REPL-driven development for music in many ways. And so the idea of communicative programming being that we think not just about how to talk to the computer in its own language, that it's faster, but we talk to each other using the computer's language so we can reason about things and be more clear and precise. And can we change our languages such that there's some interesting middle ground? So not just to make things fast and efficient in terms of the computer's interests, but fast and efficient in terms of human interests. And one of the side effects of focusing on this latter part is that you can think about education. You can go into a school and teach kids how to code. Right? Kids don't give two monkeys about whether it's fast or slow, or uses memory or doesn't use memory. They don't care about the difference between bubble sort or quick sort. That's not interesting to them. They want to see something sorted. Right? One thing I've seen a lot of when you go into schools is that kids have their own ideas about what they want to do in the world. And if you don't talk in that language, they're not necessarily interested. Unless they're weirdos like us, who, for some crazy reason, find programming interesting in its own right. That's not something that most people are really inclined to think about. So I'm sort of taking a round trip to really talk about the fact that I want to really talk about human interaction with languages and with programming environments, to use programming as a way to structure and think, and also to think about how we can take those ideas and apply them to different domains, such as education and such as the art. And so I made some notes actually just a couple of minutes ago. Thought I'd better have some notes. So I'm Sam Aaron, right? This is notes. This is me on Twitter if you want to follow me. And I'm going to talk to you today about communicative programming, talking to computers and talking to people and thinking. So I've said that already, that's great. Good, what else am I going to talk about? Education and sharing, we've talked about that. So if you can make something simple to understand, then it's easy to transfer that knowledge from one person to another person. I think that's really, really important. And that's important in business as well as important in education. If it's hard to read the code, no matter how fast and efficient it is, that's not necessarily as useful as something that's easy to read. It's not true for all parts of the code, but I think it's true for most. So simplicity of communication. What else am I talking about? I'm going to talk about art and expression. I really believe that code is one of the most powerful, exciting mediums we've ever invented, and it frustrates the hell out of me that we mostly use that power for business. What the hell? Seriously. It's like if we only used English to make contracts. Like, think of all the world that we're missing out on if we only use language to describe business relations. Oh, that's nuts. We wouldn't have rap lyrics, we wouldn't have letters, we wouldn't have poems, we wouldn't have stories or plays. What are the equivalent of those things that we could be writing with our skills in programming languages? That's what excites me. And what are the new ways as humans we could express ourselves using code? And I think that this is all wrapped together because if we make things simple, then it allows us to start thinking about how we might actually use code to express ourselves, rather than I've got a really hard technical problem, I'm going to spend 2 weeks or months solving this. It'd be interesting to think about how do I actually talk with code, or how do I dance with code, or how do I make music with code? How do I express myself, whatever that might mean to you? These are all related. And what else have I got? Yes, this is important. So I want to talk to you also about how I go about thinking about these ideas and building systems. So this Sonic Pi system I'm using just as a text editor really at the moment. I've developed not using this hammock time notion. I think that it's lovely that Rich spent a lot of time sitting in a hammock and thinking about lots of things and then figuring out ways to actually solve them where one solution can cut across multiple domains. Like if you've listened to the latest, well, if it's the latest one, a recent Communicative where he talks about the spec stuff, that's a beautiful illustration of how he's really deeply thought about many problems and used spec to cut through them all. And that's beautiful. But he does that in a hammock. On the other hand, personally, I struggle to sit in one place and do lots of thinking. So what I've been doing recently for the last year is most afternoons going for a stroll for about 2 hours and walking extensively and thinking the whole time whilst I'm walking. And in my backpack, I've got an ideas book, my diary, and I've got my pen. And when I have an idea, I'll sit down and I'll write it out and I'll carry on walking. I've really found that the office place is the worst place for me. It may be great for you people, but for me, it's the worst place to work. It's the worst place to think. It's the worst place to do anything unproductive. I go to the office when I want to be disturbed. Right? When I want to work, I'm not in the office, I'm out. I'm at a coffee shop, I'm walking, I'm sitting on top of a hill or under some bushes if I need some shade. And I have found I'm much more productive that way. And so for me, physical activity is really key for this. I don't know why, that's not really related, but it's an interesting point. And what else am I talking about? And communication over time. So this is the diary idea. So the thing is that when you really want to think deeply about something, you want to simplify it, it's not necessarily the simplest job in the world. We use simple twice in different ways. That's frustrating. What do I mean by this? So when I'm trying to build tools for education, say, right, this system here I'm showing you here is a tool which is open source and freely available that allows children and adults alike to make music out of code. One of the goals of that, therefore, is really how to make sure that kids can actually use it. It's all great and fine to talk about crazy type systems, but to go into a school, or whatever complicated thing it is, to go into a school and say, right, before you can do anything, these are all the things you need to learn before you can even start. Unless the child is like super able to do delayed gratification, right, to a crazy extent, they're not going to be interested. So somehow you need to find a way to simplify and package your ideas in a way that they can understand. And so that actually turns out to be really, really hard. Well, I found it really hard. I found it really easy to come up with lots of ideas about things, but then to think about how do I make that idea into such a way that a 10-year-old child can understand that, I found a very, very difficult problem. And so one of the core philosophical designs of this Sonic Pi system is every idea in this I can teach to a 10-year-old child, an average 10-year-old child. And that then means that I have lots of technical ideas, and people say, Sam, Sonic Pi should do this. I'm like, yes, you're right. I could build that tomorrow, but it will be like some crazy complicated implementation that wouldn't be super general, and then when I put it in front of a child, they won't understand it. So I'm not going to build it. And so what I tend to do is I have lots of ideas I'm thinking over concurrently, over periods of years sometimes, and those ideas are all floating around in space, and I'm using the diary as a way to try and keep track of them, and the walking as a way to think about things, because obviously, in the same way when Rich built the spec thing, one of his clear concerns was, I just don't want to do generative testing, I want to also do documentation, for example. How do I make sure this thing solves both problems equally well? And other problems too, as he started talking about in the general case of code distribution, and labeling. And so having a practice diary or a diary for thinking about ideas has been a really invaluable part of my development process. Is this making any sense? I don't know. And what else am I talking about? State of mind. Right. This is the final point, and then until someone tells me to stop, I'll keep on rambling. This is really important because when I'm designing a system, it's really easy for me to go to a whiteboard and just do some blue sky thinking, right? And think, oh, it'd be really cool if the system did this and that and the other, right? And often those ideas are totally rubbish because they might be great in the moment where I'm standing next to a whiteboard, but when I'm using this system, there's no whiteboard. There's no lights. I'm in a nightclub. It's dark, right? And the constraints I have are fundamentally different. At the whiteboard, I can stand there and pontificate for ages and think about things and go for a coffee. In the nightclub, I need to make music, and it needs to keep changing. I don't have that time. And so the constraints of the use case are actually really, really fundamentally important in terms of how you might think of a solution or reason about a solution. If I have a range of possible solutions, they might look great on the whiteboard. This one looks the best on the whiteboard. This looks technically beautiful, philosophically ideal. But then the practical constraints just rip it apart. And for me, the practical constraints I've already mentioned are being in a sort of a music environment, so a performance environment, but they're also in a school. And if the teacher can't understand it, or the child can't understand it, or if it doesn't make it itself clear, then however beautiful and ideological your idea is, it doesn't necessarily roll at all. And so it's been really important for me whilst designing this system so instead of designing a system for live coders, I had to become a live coder. It's almost auto-ethnographic. And so in the practice state, so I do this walking thing and thinking about ideas, and that's all sort of blue sky, but then every day I do about 2 hours of live coding practice. And in that practice, I have lots of ideas that come to me whilst I'm making music, thinking, oh, I wish I could make the music do this. And instead of stopping and starting to develop those ideas, which is what I did when I was working on Overtone, and then 2 hours later have some half-broken code that sort of maybe possibly solve the problem, I now take my diary out and asynchronously write down a couple of notes and then carry on practicing. So I'm in this flow of the context I'm in. That flow gives me ideas and problems that are really important for the context, and then make sure I have an asynchronous log of those ideas, such that I can then go back later when I'm walking, or if I'm just in the bath, or if I'm sitting on the sofa, and I can read this diary and go, oh, that was a terrible idea. Oh, that was a really good idea. And so then I'm able to then, over time, to bring these ideas in some sort of way that I can then figure out which ones I should work on next. Does that make any kind of sense? Yeah, so I don't know, how long have I got left? Is it 5 minutes? 5 minutes, right. So I thought I'd give you a couple of examples of this kind of thinking. So I don't know if you've ever seen these. Obviously, your program, the amount of boilerplate code in any language you have to write is nuts, right? So if you go into a school and you say you've got to create a project, then you've got to write boilerplate code, right? The kids are like, what the hell is this? Teachers are, what the hell is this? So Sonic Pi, you just write the word play, and you choose a number, and you press run, and it makes a beep, right? So this is the first program you can possibly write. You can do this if you want, this also works. And so this is the idea, is trying to make things as simple as possible, but every aspect of the system, to make it as simple as possible, is critical. So if I wanted to do like a loop, do a sample bass drum house, and sleep for half a beat, and end, that's pretty cool. I can get a bass drum going. But if I wanted to do two of those, well, maybe one's playing this and someone's doing like a drum and bass and then, wait, yeah, that one, yeah. This one, let's go for 1 minute. Right, let's run this. So we're going to play the house drum and the bass drum, the bass at the same time. Oh, it doesn't work, obviously, right? We're in an imperative language. The code goes into loop at the top and stays there, obviously. It's sort of like a black hole for computation. But kids want to write this, right? This is obviously an intuitive thing. They all try this, and they get frustrated when it doesn't work. It's, well, programmers, we have all sorts of crazy stuff. So either you could interleave these things, which maybe in some cases is quite simple if it's nice round numbers, but if this is like 0.3, this is hard to interleave. Or you use threads. Right, obviously, then in schools, we don't teach threads, we teach them at university level. And so this is a way, how do you think about solving this problem in such a way that it maintains the simplicity? So I have this thing called, let's go back to 1. Oh, I can't type. It's a live loop. I don't know if you've seen this yet or not. Live loops are like loops. I run this code. It doesn't run. I got an error here. It says live loop needs to have a unique name. For example, live loop foo. So now I need to give them names, okay, foo. And, well, actually, these live loops are instrumentalists. So this is Sally, and this is Peter. And now they work at the same time. So this is a case where you want to have something simple, constructively, that matches the ideas, but obviously behind the scenes, this is extremely complicated. It's not extremely complicated to you guys, but to lots of other people. I mean, I'm combining functions and threads and loops in the same place. Why am I using functions? Well, another thing you want to be able to do is to be able to change this stuff on the fly. So that you're not losing the beat, but you're modifying the code. So this is why I'm using functions. So the threads are running, allows concurrency, and the loop is then dereferencing a function. If I modify the function, the next time it dereferences it, then it uses the new version that allows me to update it, all whilst keeping time. That's the other thing. This sleep 1, oh, I'm going to fall off the stage. This sleep 1 used to be like standard POSIX sleep, where I would sleep for 1 second, but that doesn't work with music, because that says the scheduler, after 1 second, I'm ready to pick up, so it adds a delta of delay on top of that. Also, not this line, well, let's uncomment it. That line there, line 2, has some time for the computation to work. So every time round, I'm waiting for 0.5 plus a delta and the computation time of line 2, which after time drifts. And if those computation times are different, then they drift in different ways, and then the GC kicks in. Boom, you've destroyed your time. And so, again, this is an important point where you need to think about, how do I maintain the simplicity of the sleep 1, but gain the accuracy of a real musical system? So again, although the solution, I mean, I'm saying like, this is exciting. Look at that, sleep 1, right? But the amount of thought that went into how to actually re-implement sleep such that it had the same semantic or syntactic construction, but had a completely different semantic meaning, but actually worked in the way that you actually expected it to, was really, really a lot of work. And the last thing I want to show you before I stop, which is the latest exciting thing, is this, right? If I have a loop arm end break, that's pretty cool, right? I can sort of I can change the rate. As you've seen before, change it like that, or I can do -1 for reverse. I mean, already that was actually quite a lot of work to build a synthesizer in overtone that allowed me to just change the rate backwards and forwards by changing the polarity of the number. But one thing that people do all the time is they say, well, okay, I've got this complicated sample, but I only want to play the first drum, or the third one, or the fifth, or I've got a bass line, I want to play the second note. How on earth do you do that? Well, one option is to get it into like a wave editor and then find all the onsets manually, find the times, and then compile into this and write the times in, and that could work. Or, and this has taken me a long time, right? This has taken me a long time to come up with this idea. And I'm really excited about it, but it's not going to be very good to look at, right? Watch. Onset, 0. Oh, yeah. This is amazing, right? So now I can treat a WAV file as an array of individual hits, which means I can do this. Right, so I'm just repeating that note. I'm going to use an envelope over it to make it short. All right, there we are. And so now I can start live coding this around. I can use like rings, tick through them. There we are, right? So this is quite fun. But one thing that people always want to do is to be able to just play a random thing in there. And so this was another thing, is how do I make sure that it's really easy to play a random onset? And I need to somehow know how many onsets there are. That's unknown ahead of time. It depends on the algorithm, which does the feature detection. So I can't, ahead of time, know there's 16 onsets or 5 onsets. And so I need some simple way to do that. So the solution, again, this is after a lot of walking and thinking, is just to have a function which is a lambda, which takes the list of all the onsets, the parameter, and then chooses one for you and returns it. But in a way that the children can just write pick. And now we have a randomized thing, which is going to play forever, which is like kind of like the music from the 90s, right? But in 4 lines of code. 4 lines of code that I can teach to a 10-year-old child. Now, I've run out of time, but all the ideas I've just shown you now, I could show you the original versions of the first iteration, and they would be incredibly complicated. The live loop was threads and functions and definitions. This onset was lambdas passing in and functions of functions going through here, which I'm sure you would understand, but if you go into a classroom, it's gone. Or when you're performing, you don't want to be writing all those lambdas and thinking about all those lambdas. You just want to write pick. And so the one I want to try and talk about is that when you think about programs in a deep way, that's obviously a beautiful thing. But when you add constraints, such as, I would like all the code I write to be understandable by a 10-year-old child, that really, really changes the way you have to tackle problems and the level of depth and the number of iterations you have to apply before you come to a final solution. And I think that's a beautiful thing. So I would all get you to think about how you might think about things in terms of expressing things clearly, and I recommend you all get out of your hammocks, get out on the fields and do some big walks. Thank you very much.